D and E are points on the sides CA and CB respectively of a triangle ABC right angle at C. Prove that AE square plus BD square equal to AB square plus BE square. In the first step, we are going to find out what is AE square. So this is AE square, this is AE, and if you see AE is part of the triangle ACE, which is 90 degrees HC. So we'll use Pythagoras theorem in ACE. So triangle ACE, angle C equal to 90. So Pythagoras theorem, hypotenuse square AE square equal to AC square plus EC square. We put this equation 1, and this is by Pythagoras theorem. Now next we need to find BD square. So we'll just darken BD square in the figure. So BD square, here is B and this is D. So this is BD square. To find BD square, we need to take up the triangle DCB, which is 90 degrees C. So for the next, we'll take up triangle DCB and angle C equal to 90, which means now the hypotenuse is BD. So BD square equal to DC square plus BC square. Equation 2, also by Pythagoras theorem. Now that we have found out AE and BD, the next step is to add up AE and BD square. So we need to add equation 1 and 2. So here is equation 1, this is equation 2, and we go ahead and add it up. So we'll get AE square, this is square, BD square equal to AC square plus EC square. This is the blue, and now I'm drawing the yellow. DC square plus BC square. This is where we've got. Now look up in your figure again. We know AC square plus BC square is equal to AB square. Let me write that out here. So that is in triangle ACB. So we have in triangle ACB, again right angle at C. AB square is a hypotenuse. This is a hypotenuse AB. So we have AB square equal to AC square plus BC square. We'll put this as equation 3. Similarly out here, we see that DC square plus EC square, because this is 90, will be equal to DE square. So I'll write that too. So in triangle DEC, again angle C is 90. So DE square equal to DC square plus EC square. 4. All by Pythagoras theorem. These two by Pythagoras theorem. Now look at the statement very carefully that we have written. If I take AC square and I take BC square together, I'm going to take that together, and you'll understand why I'm taking these two together. And then I'm going to take EC square and DC square together. Further, I just write this now, AE square I'm just copying the first statement. Now look up and see what is AC square plus BC square. It's out here. AC square plus BC square equal to AB square. And next, check out and see what is EC square plus DC square. We've done it here. And that is DE square. So we have proved the statement they've asked us. You say this is by 3 and 4. So, and it is proved. So here basically you had to use the 4 triangles and use the Pythagoras theorem in each of these triangles. The perpendicular from A on side BC of a triangle ABC intersects BC at D such that, this is important, DB is 3 times CD. Prove that 2AB square equal to 2AC square plus BC square. The step 1 of the sum is this. Now look at BC. If you look up at BC, what is BC made up of? This is BC, C and B. So here is BC. And you see BC is made up of 2 parts. CD plus DB. So that's what I'm going to write first. BC equal to CD plus DB. So BC equal to, but it's given to me here that DB is 3 times CD. So for DB here I'm writing 3 times CD because it is given. The reason for this, or rather the reason this side, DB equal to 3 times CD. So the BC now is equal to 1 CD plus 3 CD became 4 CD, which means BC by 4 equal to CD. I'll rewrite this again. So I have CD is 1/4 of BC. Let's mark it in the figure. So this was our CD here. Earlier we marked it. And we said CD now, let's mark it thicker. This is CD. It's 1/4 of BC. So the other half is DB. What would DB be? It will be definitely 3/4 of BC. The rest, 3/4 of BC. So here for BD, I'm going to write 3/4 of BC. 1/4 plus 3/4 becomes 1. So I'll write this as equation 1. Now we go to the second step. We need to find AB square. So let's go and see where is AB. So here is A and here is B. So to find AB, we need to use the triangle ABD. ABD. Here is a 90 degrees and the hypotenuse will be out here. This will be the hypotenuse. So I'll write AB square equal to AD square plus DB square. So in triangle, this is my second step, in triangle ATB, angle D equal to 90. Therefore, AB square equal to AD square plus DB square. Equation 2 by Pythagoras theorem. I have yet another right angle triangle, and that right angle triangle is ADC. So we have ADC, this right angle triangle, and I'm going to use Pythagoras theorem. This is the hypotenuse. So in triangle ADC, we always require 90 degrees for Pythagoras. D, you've got to indicate your 90 degrees. D equal to 90. So we have AC square equal to AD square plus CD square. This is equation 3 by Pythagoras. In the next step, we're going to subtract equation 2 and 3. So here are two equations, and we're going to subtract 3 from 2. So subtraction, we've got to change the sign. So the plus here becomes minus, the plus here will become minus, the plus here will become minus. We'll get AB square minus AC square plus AD square minus AD square will cut off. So this would be DB square minus CD square. So AB square minus AC square. Now do you recollect what was A square minus B square? A minus B, A plus B. So that would be DB minus CD and DB. No, we don't need to do this. We could just straight away substitute. Earlier, remember, we have already found that DB equal to 3/4 of BC and CD equal to 1/4 of BC. So let's put those values here, the DB value here minus the CD value here. So this is 3/4 BC and here 1/4 BC. We'll go ahead. So AB square minus AC square, this is 3 square, so 9 BC square over 16, and here BC square also over 16. So we have AB square minus AC square, here LCM is 16, so we have 9 BC square minus BC square. AB square minus AC square, 9 minus 1 is 8 BC square over 16. So now we have AB square minus AC square. We reduce this and we get BC square over 2. Now I take the 2 on the other side, so I have 2 into AB square minus AC square equal to BC square. So 2AB square, open the bracket, 2AC square equal to BC square. I take the AC square the other side, so I get 2AB square equal to BC square plus twice AC square. And this is proved. This is exactly what they have asked you. Let's go over the sum again. Just summarize it. In the first step, you had to take here, this was CD, and the CD you worked it out as 1/4 of BC, and then you had DB or BD, and that was 3/4 of BC. This was the first step. Then the next step, you'd use Pythagoras theorem, and you found out what is AB square, and you wrote AB square equal to AD square plus DB square. Then you use Pythagoras theorem in the other triangle for AC. So you have here AC square equal to AD square plus CD square. Next you subtracted these two. So on subtracting, got AB square minus AC square, this cut off. So you got TB square minus CD square. Then you added these values. For CD you added this value, for DB you added this value. So here you did 3 by 4 BC the whole square minus 1 by 4 BC the whole square. And you work this out. And on working this out, you got AB square minus AC square equal to BC square by 2. And you cross multiplied and got your answer. In an equilateral triangle ABC, D is a point on BC such that BD is 1/3 of BC. Prove that 9AD square equal to 7AB square. Now the figure is not given to you. You need to draw your figure. So we have drawn an equilateral triangle ABC here. So you have A, B and C. And this is an equilateral triangle. All sides equal. And they have taken a point B or point D such that BD is 1/3 of BC. But we'll take this up a little later. For now, we will draw a perpendicular. This is the perpendicular we draw in our first step. So this we know is 90. So in step 1, the sum is rather long. You got to study it in steps. So in step 1, in triangle ABC, we construct AE perpendicular to BC. Now by the properties of an equilateral triangle, both these sides, the perpendicular always bisects the base. So we'll have BD equal to EC. That is by property of equilateral triangles. So then you write BE equal to C. We will use this later. An altitude from the opposite vertex or perpendicular from the opposite vertex bisects the base. We keep this. We need this later to use, wherein we showed that BD, here we showed BD was equal to EC. And let me write it out here because there are too many things in this sum to remember. So we have B here, we showed BE equal to EC, first step. Now in the second step, it is given to us that BD is 1/3 of BC. So which means now, this is BD, here B and this is D. And they said this BD is 1/3 of BC. So this is 1/3 of BC. Therefore the remaining part, and which is the remaining part, is DC. Now this remaining part, you will agree, will be 2/3 of BC. So this is again the second thing we need to write and keep it. So it is given to us that BD, here see, BD equal to 1/3 BC given. Therefore, we can write DC is the rest. Rest of 1/3 is what? 2/3 of BC. So this, I will put both these statements as equation 2, which I will need to use later. Now in this sum, remember, we need to show 9AD square equal to 7AB square. This is where we need to reach. So we'll take up AB square. Where we will get AB square? This is A and B. So on joining, we get AB square here. So if we want to find AB square, we have to take up the triangle ABE. Okay, so let's do that. So we have triangle ABE. Always mark your 90 degrees before you use Pythagoras. Here this is the hypotenuse, AB is the hypotenuse. So I'm going to write AB square equal to AE square plus BE square. Now next I need AD square too. So how do I get AD square? This is A and this is D. So if I want AD square, I got to take up the triangle ADE, this triangle. Let me draw it again. Yeah, this triangle. So in triangle ADE, the blue triangle, we have E equal to 90. The hypotenuse, this is 90, so hypotenuse is 80. So AD square equal to AE square plus DE square. Pythagoras, this also is by Pythagoras. It's time to subtract both these equations. This would be equation 3 and equation 4. So I subtract 4 from 3. Subtract will change the sign. So this will be now AB square minus AD square. This will cancel out, plus and minus. I have BE square minus DE square. So I have AB square minus AD square. Now look at BE square minus DE square. A square minus B square. So this is A plus B and A minus B. So again, AB square minus AD square equal to. Let's take up to this bracket. What is BE minus DE? Look up at the figure and let's see what it is. So this is my BE, and from BE I am subtracting DE. What am I left with? BD. So that's what I'm going to write here, BD. For the next part, if you remember earlier, we showed that BE, by property, BE was equal to EC. So that's exactly what I'm going to substitute here. Now let me write that again. So we had showed earlier by equilateral triangle property, BE equal to EC. So for this BE, I'm going to put EC, and the rest I just copy. This is the reason we have proved earlier. Now we go again, AB square minus AD square equal to. Now again go back to the figure and look up what is EC plus DE. Let's look up in the figure. We have DE here, and then we have EC. This is EC. So DE plus EC is DC. So here I'm going to write now DC. And this of course was BD. It would do you good if you write the reason here also, that BE minus DE equal to BD as a reason, and EC plus DE equal to DC. So I have AB square minus AD square equal to. Now again, when we went back, we had shown that BD, if you remember here, we showed BD was equal to, here BD equal to 1/3 of BC and DC equal to 2/3 of BC, and this value we are going to use it. So let's put that value. For DC we showed it was 2/3 of BC, and BD we showed 1/3 of BC. So this was copied from the last slide. So we have AB square minus AD square. 3 into 3 is 9. BC, BC, BC square. So I have AB square minus AD square. Now 2 by 9. For BC square, I'm putting AB square. Could you think what gives me the permission to do this? Because AB, of course, equal to BC. Why? Equilateral triangle. In equilateral triangle, all the sides are equal. Now I cross multiply, I get 9. AB square minus AD square equal to twice AB square. Open the bracket. 9AB square minus 9AD square is twice AB square. I take all the AB terms together, so 9AB square minus twice AB square equal to minus 9AD square here plus 9AD square. So 7AB square equal to 9AD square, and I proved it. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of its altitude. So first we need an equilateral triangle. So given triangle ABC is equilateral, and then we need an altitude, right? So we do AD perpendicular to BC, and we need to prove 3 times the altitude equal to 4 times. It's 3 times, I'll just put it up here, 3 times the square of the side equal to 4 times the square of the altitude. That's what they're saying. So 3 times the side here is AB, 4 times the altitude, square of the altitude, that is AD square. So we start out our proof. So we have the proof now. First important part, we know BD equal to DC. We did also in the last proof. These two will be equal, and why they are equal? It is by property of equilateral triangle. Reason for this, the altitude or perpendicular to the base bisects the base. This happens in equilateral triangle, and we're going to use this later. So if BD equal to BC, so I can say that BD is half of BC, and this is what I'm going to use later. I'm going to cancel this up. Now it's time to use my Pythagoras theorem, and I'll use Pythagoras theorem in AD. Yeah, use the Pythagoras theorem in ABD. Angle D is 90. AB will be the hypotenuse, so AB square equal to AD square plus BD square. So AB square equal to AD square. Now for BD, I already have found BD is BC by 2. So I'm putting here BC by 2 the whole square. Then I carry on. So I get AB square equal to AD square plus BC square by 4. Now I take LCM. I will take the LCM. AP square equal to, this is 4 AD square plus BC square. Now cross multiply, so 4 AB square, 4 AD square plus BC square. Now remember, this is an equilateral triangle. All the sides are equal. Here I just copy this out. Now for BC square, I'm putting AB square. But all sides are equal. AB equal to BC, side of equilateral. So I have 4AB square equal to 4AD square, and here I put the AB square. So in this case, I should have, in this step, I will do minus AB square, 4AD square. So 4AB square minus AB square is 3AB square equal to 4AD square. And I have proved 3 times the square of the side, because this is side, AB is side, equal to 4 times the altitude. AD was the altitude. Proved. Tick the correct answer and justify. In triangle ABC, they say AB is 6 root 3, AC equal to 12, and BC equal to 6. So AB square will be 6 root 3 the whole square. So there will be 36 into 3, which is 108. Now AC square is 12 square, 144. BC square, 6 square, 36. Now take the two smaller sides, and the two smaller sides will be AB and AC, and add them up. So let's add AB square plus BC square, 108 plus 36, which is equal to 144. And if you notice, that is equal to our AC square. This is equal to AC square, which is also 144. So here we have AB square plus BC square equal to AC square. So by converse of Pythagoras theorem, we can say that triangle ABC is right triangle. By the converse, you got to write it by the converse of Pythagoras theorem. And who must be the hypotenuse? AC must be the hypotenuse. So if AC is hypotenuse, angle B will be equal to 90. Let me draw the figure. So I have here AC is hypotenuse. So this angle B must be 90 degrees. So they said angle B would be 90 degrees.